All right, question number 10. This one says the number of hits to a website follows a Poisson process. So this is a Poisson. This is one that we will omit, but I will show you how to work it. So it says hits occur at a rate of 1.7 per minute between 7 and 9. Given below are 3 scenarios. Compute the probability for each scenario between 8:41 and 8:49. And then it says interpret each result. So the Poisson distribution is given by this formula, probability of x, and what this is doing is counting how many successes happen in time interval. That is equal to lambda, which is this upside down y shape, lambda to the power of x divided by x factorial times e to the power negative lambda. Okay. Lambda is the mean. We're going to compute the mean by doing time interval times the expected number, so times n. In this case, we are going from 8:41 to 8:49. Time times, I guess I should say rate. Let me just put a R here. Rate will be a better one. So the time is 8 minutes. The rate was 1.7 per minute. So when the minutes on top and minutes on the bottom will cancel out, we're going to do 8 times 1.7. It's 8 and 7 is 56. 8 and 5 is 13. So we get 13.6. So this is equal to lambda. This is the only thing we need. We figure out lambda. How many would we expect to happen in that 8-minute interval, which is here? We need lambda, and then the first part says find the probability of 6. So probability exactly 6. So we're going to do this with Excel. We can punch this in the calculator, but again, we're just going to do it with Excel. That'll be a little bit faster. So in Excel, we're going to go to formulas, more functions, statistical. They're in alphabetical order. We're going to look for that Poisson. Not pronounced poison, it's Poisson. It's a French name, I want to say. So Poisson right here. We input the number of success that we want, which we want 6. The mean, which we found, that's the lambda, so 13.6. And then the cumulative, it tells you right here a logical value. If we want the cumulative distribution, CDF, we put true. For the mass, we put false. So mass is the PDF, and that's what we want. We want exact. So we're going to put false here. When I do that, it gives me the probability here, 0.0109. So that's my probability, 0.0109. Okay, so then we have to interpret that. So it says on about blank of every 100 intervals here. So this is the probability. If you multiply that times 100, because we're talking about 100 times, you get the exact percentage, which is 1.09%. Now it says round to a whole number. So this means 1. So basically 1 out of every 100 intervals, 8 minutes long right here, the website will receive exactly, because we want exactly 6 hits. Next, We want to know probability less than 6. So I'm going to interpret that probability X is less than 6. When we do the cumulative, it does less than or equal to. So less than 6 would mean 5 and below. So this is the same thing as saying probability X is less than or equal to 5. So this is the one I want to compute. We're going to do the same thing. So I'm going to come over here to Excel. I'm just going to click in a different cell, more functions, statistical, go down to the Poisson. Right here. This time we're going to put a 5 because less than 6 is the same thing as less than or equal to 5. Mean, still 13.6. And the cumulative is going to be true this time. We do want cumulative. We get 0.0072. Okay. And then we need to write what that means. We're going to interpret that. So it says on about blank of every 100. So same like the previous one, we're going to round to the nearest whole number. So if I take this probability, multiply by 100, it's going to equal to 0.72%. When rounded to a whole number, that's going to be just 1. So 1, again, out of every 100 intervals, this width, we would have fewer than 6. And then this one wants greater than or equal to 6. So with greater than, the way we compute greater than is 1 minus the probability that we're less than, which is what we just got here. So 1 minus probability that X is less than, we can say less than 6, which is basically the same thing, 1 through 3, 4, 5. Instead of 6 and above, we want to get rid of the lower half, so I'll just say X is less than or equal to 5. So it's the same thing we just did up here. So less than or equal to 5 is 0.0072. So we're going to do 1 minus 0.0072 gives us 0.9928. And then, so if I multiply that by 100, that'll give me about 99. Out of every 100 intervals, we'll receive at least, because we want 6 or more, so at least, that's the way we say greater than or equal to, at least 6 hits.